Welcome to video of theory of machines. We are going to discuss about module 3 contents, the theory of machines. In the module 3 we are going to study about the different gear technologies, spur gear, helical gear. In the spur gear you will be knowing about what is the law of gearing, how to generate different type of gear tooth profiles, and in the gear trains we will be discussing about the simple gear train, compound gear train, epicyclic gear train, how to find out the velocity ratio when we compound different type of gears. So when we talk about different type of wheels, we have got spur gear, we have got parallel axis contact, we have got internal contact, and we have got parallel helical gears, ring bar gears, like this different type of positions of the axis of shaft, where you'll be able to get the transmission of the gears to be used. So based on the application, based on the need, you're going to select a particular toothed wheel gear so that you'll be able to get the required motion. So classification of toothed wheels is intersecting gears. You can see that is a bevel gear, that is a spiral bevel gear. The spiral bevel gear you can see once again the tooths are crossed. So once again the tooths are parallel to each other. So that is then a straight bevel gear. If the tooths are cut in different profile, that is then a spiral bevel gear. So here what all we need according to transmission, according to the contact, according to the power generation you are supposed to decide. When the shaft axes are non-intersecting and non-parallel, we'll go for this type of gear. So crossed helical gear you can see when the gears are cut in the helical shape and the wheel moves. So here you can see the advancement happens. So worm and worm wheel you can see the wheel it has got a worm structure. So the wheel it has also the worms tooth form mates on both surface and it is going to have motion. So based on the velocity need, we are going to select a particular wheels, low velocity, medium velocity, and high velocity. This low velocity, then the speed is less than 3 meters per second. Medium velocity means it is 3 to 15 meters per second square per second. If it is high velocity more than 15 meters per second, we are going to achieve. So once again, the type of gearing what you did may be internal gearing, external gearing, rack and pinion we can expect. So if it is external gearing, the tooth will be having the outer mating surface. If it is internal gearing, the existing gear, it will be having tooth form in the internal surface, so that another gear will be mating internally. So there will be rack and pinion on the surface where it is going to move. So in the rack and pinion, what we can see is there will be a tooth form where it is going to engage in one surface. So there will be a tooth form in the horizontal position. The shaft will be connected on this spur gear where it is going to make motion on the surface. So when you come to spur gear terminology, this is the profile of a spur gear. The spur gear there will be addendum, dedendum. That is the addendum is the top face, dedendum is the lower surface of the tooth. So in between those two, that is known as addendum circle between the two tooth space. So top face it is known as the top band. So the length in the third direction that is known as the face width. So the remaining it is with respect to the circle what we draw. So where the tooth is going to engage that is known as the working depth. So the at the center the line what we draw that is known as the pitch surface element. So like this, these are all the main parameters where it is considered to consider the spur gear. So all these parameters must be considered. So further, we are supposed to give some clearance so that the other tooth gets engaged in the space. It must be able to engage properly. So there must be clearance or working depth circle must be there so that it is going to get advanced. So terminology is this per gear. Here it is the pressure angle or it is also known as angle of obliquity. So it is the common normal to two gear tooth at the point of contact, common tangent at the pitch point. So it is usually denoted by phi. So the standard pressure angle for the spur gear it is 14.5 degree and 20 degree. So when it is going to mate, both the gears must have same pressure angles. So further the spur gear it is counted with the pitch, circular pitch. It is the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point of the next tooth. So PC is equal to pi d divided by t, where d is the diameter of the pitch circle, where t is the number of teeth on the wheel. So here PC is equal to pi d1 by t1, that must be equal to pi d2 divided by t2, or it can be noted by t1 by t2 is equal to t1 by t2. So like this we must be able to have connectivity. So terminology of this per gear how you take is the ratio of number of teeth on the pitch circle diameter, it is denoted by PD, that is equal to t by t. T is equal to number of teeth and d is the pitch circle diameter. So here that is also equal to pi divided by PC. PC is equal to pi into t divided by t. So further module, what is the module of the spur gear? It is the ratio of pitch circle diameter to the number of teeth. That is small m is equal to capital D by divided by t. So the recommended standards for module it is 1, 1.25, 1.5, 2, 2.5, 3, 4, 5, 6, 8, 10, 12, 16 and 20. So like this different modules are considered for going with this spur gear terminology. So what is the backlash in the spur gear? It is the difference between tooth space and the tooth thickness which is measured along the pitch circle. So backlash should be 0, but in actual practice some backlashes must be allowed to prevent jamming of teeth due to tooth errors and thermal expansions. So backlash it's an important part what we consider. So just if you make forward and backward motion of a gear, you'll be able to come to know whether it is having backlash or not. So how to calculate the center distance? Center distance is equal to teeth on pinion plus teeth on gear. So that is equal into circular pitch divided by 2 pi, or teeth on pinion plus teeth on gear divided by 2 into diametral pitch. So what is the base circle diameter? Base circle diameter is equal to pitch diameter into cos phi. So what are the standard formulas used to used for the gears to with the standard teeth is, if you want to calculate addendum, 0.3183 into circular pitch. Dedendum is 0.3683 into circular pitch. Working depth is 0.6366 into circular pitch. Hole depth is 0.6866 into circular pitch. Clearance, if you take 0.05 times into circular pitch, outside diameter is teeth plus 2 into circular pitch divided by pi. Diametral pitch is teeth plus outer divided by outside diameter. So what are the gear materials needed for the uh, for the spur gear when we design? So selection of material depends upon the strength and service conditions like wear and noise. Metallic materials like cast iron, steel, and bronze are selected. Non-metallic materials reduces noise. Wood, compressed paper, synthetic resins like nylon. Like this, different materials are considered.